All right, welcome back to statistics. We are going to continue talking about correlation coefficients here. So let me go ahead and share the screen and get into that. All right, so what are we doing? We're trying to, 2008, it's ancient history now. We are trying to figure out the predicted price of milk depending on the price of gas, or the eggs rather. Some of you, especially the people that are better in algebra, had some good experiences in algebra. You might be wondering, like, well, why don't we call them dependent and independent? Well, independent and dependent mean different things in statistics, okay? We call them explanatory and response. Okay, now, this particular problem, like, well, how do you know that the eggs are explanatory and a gallon of milk is the response? Like, because that's how they set up the problem. So really, both would have been correct, honestly, but they, depending on which one you measured and tried to predict from the other. Okay, but there's no like real reason as to why one is explanatory and the other one is response in this case. So usually this book does not go out of the way to fool you. I am not going out of my way to fool you. The first variable they give you are the x values, the explanatory ones. The response would be the y values. Okay, so that's the second variable they give you. Okay, so I have a feeling this is going to go disastrously wrong because I've tried it and they are very picky about their little piece here. So we are going to plot these points. All right, and here's what we're going to do. We're just going to type them in. Okay, this is 1.67. And the next one is going to be 3.43. So 3.43. Okay, plot the point. Okay, and we're just going to go through this the entire time. So 1.94. All right, sorry for this. 3.52, 3.52. Okay, what's the next pair? Actually, I'm gonna do this. This is how you guys are gonna be doing your quizzes. We're not plotting and making scatter plots on your quiz. Okay, so I'm not doing this to you because it's too easy to type in something that was just slightly wrong and get the whole thing wrong. We're not doing that. Okay, 1.96 tab 3.47. Plot that point. Okay. And now we have 1.77 and 3.58. That's the next one down here. So we are plotting 1.77 and 3.58. All right. Next one is going to be 1.80, 1.80, and 3.47. Okay. Just in case you thought, like, well, it's got to be easier for him. No, we're all human. We're all stuck with this. Okay. Next is 1.88, 3.54. Okay. 1.88, 3.54. Plot. All right. 1.83 and 3.58. 0.83, 3.58. Okay, and 3.58. What? Okay. I think this is the last one, 1.65 and 3.43. All right, so 1.65 and 3.43. What? All right. Oh, there it is. Pick our answer. Hooray. All right. We've conducted a scatter plot. That's great. That tells me less than nothing. I have no idea what that's trying to tell me. There's kind of a trend here. Okay, if we don't worry about these 2 points, there's kind of a trend. But so let's see. All right. So if we go back to here, we go up to our points. So what I'm going to do is I'm going to go to my statistics. I'm going to go ahead and clear my list. So we're going to hit clear list. So we're going to hit list 1, comma, list 2, done. All right. So now we go back to our stats and we're going to edit those lists. All right. So 1.67, 1.94, 1.96, 1.77, 1.80, 80. There we go. 1.88, 1.83, 1.65. Enter. All right. Next ones. 3.43, 3.52, 3.47, 3.58, 3.47, 3.54, 3.58, 3.43. Looks like we're pretty good as far as that goes. Been a long time since I had to do that by hand, so double check. All right, looks good. Now, stat, go over to tests. So stat, tests, and now we're going to go down to where it says lin reg t-test. Okay, on a TI-83, it's option E. On a TI-84, it's going to be option F. Enter, and again, I'm not changing anything. List 1 is the X variable, list 2 is the Y variable, and then everything else we're just going to leave alone and go ahead and calculate. Okay, this is coming in the next section, but we have an R of 0.418. Okay, because if they answer to at least 3 decimal places, so 418, let me double check. There you go. All right. And that should be fine. All right, very good. So that's probably the hardest part, is figuring out how to work the calculator in this section. Okay, in a month where the price of eggs is above average, would you expect the price of milk to be above average or below average? Well, this is part of the things. Correlation coefficient is a positive. Okay, so it's a positive slope. That means for rising egg prices, milk should also rise. So if the price of eggs is above average, okay, I would expect the milk to be above average, okay, since the R value is positive. They have less positive slope there. More egg price equals more milk price. Those are the kinds of questions, by the way, you want to kind of pay attention to, because those are the kinds of things that I tend to ask with this. All right, I'm not into like making you do a lot of this. All right. Let's see here. Changes in the price of eggs or milk do not cause changes in the price of the others. Correlation indicates the prices of milk and eggs tend to go up and down together. See, I don't think they're very strongly correlated at all. So I don't like if this turns out to be the answer, if egg prices rise, it doesn't cause anything. Okay. So anytime you see this cause, like, you can immediately dismiss it because we are not looking at cause. You folks probably grew up with cigarettes being hazardous to your health. If you're Gen X or earlier, we did not grow up with cigarettes that were hazardous to your health. They were related, okay, but they didn't say cigarettes cause cancer. Okay, they just didn't. We had to go through 20 years of testing to say cigarettes cause cancer. Okay. Now they have that on the package. Okay. But when I grew up, cigarettes did not cause cancer. They were just related to cancer and emphysema and all the bad stuff you get with smoking cigarettes. So anytime you see this cause word, you can immediately throw that out. Okay, we're not checking for causal anything. All right, so that's not happening. So great. No, we're not going to be trying another. We're just going to move on. Let's see. Do we have to? No, we're not going to do another one like that. You guys, I'm kind of hoping you guys can go through the process there of doing all of that. We'll do one more. Okay. I think I have asked this question before on a quiz. Okay. So we have the left foot that we're taking temperatures on and checking out the right foot. Okay, so this is in diabetics. So diabetics have, I don't understand the disease and everything that it does. Hopefully I'll never have to, but I know that temperature regulation is an issue, okay, especially in extremities. All right. So 88 and 86. I'm just writing these down so I could type them in quickly to plot them. Okay. 78, 78. Okay. 89, 86, 76, 80, and then 80, 80. Okay. I like the people who have the same temperatures. Okay. I think they're doing pretty well managing that, but I don't know. All right. We're going to type in a bunch of points. Okay, we're going to type in 85, 85, plot it. We're going to type in 75, 80, 75, 80, plot. All right, we're going to have 88, 86, all right, 87, 82. I'm worried about this person. Okay, 78, 78. Okay, that's looking promising for that person. 89, 86. Actually, I don't know. I don't really know. I would hope it's normal for your feet to be the same temperature if you're an otherwise healthy human being, but I don't know. All right. So, all right. I like this correlation plot better. I like the scatter plot better. It's a little bit tighter around everything. So, you know, we could say like the warmer one foot is, the other foot tends to be warmer. Some people just run higher or lower temp, or their extremities are higher or lower temp, whatever. But that, I'd be happier saying that there's a linear relationship here and we could do something with this. All right. So again, we have to calculate the decimals. We have to calculate the correlation. So we're going to go to stat. Okay, we're going to go to edit. We are going to clear list 1, comma, list 2. All right, and then we're just going to re-enter these this data here. Okay, so stat, edit. All right, and we're just going to type these guys in. That's it. So what do we want? We're 85, 75, 88, 87, 78, 89. Oops, not that 89. It's too much. Delete. 76 and 80. All right, now let's see the other foot. So 85, 80, 86, 82, 78, 86, 80, 80. All right, double checking here. Do I have an 80, 80 here? Yes, I do. All right. All right, so let's go to stats, test, okay? We're going to go down to option E. I guess we can go up to option E, okay? E or F, okay, depending on calculator. Enter. Not going to change anything here. List 1 is my X variables. X2 is my Y variables. Let's just go ahead, calculate. Oops, lost it. Enter. All right, and let's scroll down to where it says correlation coefficient. 0.860, because this 3 doesn't really contribute to making that bigger, so 0.860. 0.860. Oops, I want 860. There we go. 3 decimal places, check. Okay, if the patient's left foot is cooler than the average, then I would expect the patient's right foot to be cooler than average. There's a positive correlation, right? So if we look at this, if we wanted to kind of draw a line in here, right, the warmer the left foot is, the warmer the right foot is, right? So I would choose the right foot to be a little warmer, since the average R is positive. Okay, since R is going to be positive. Okay, if it was negative, you would expect the opposite to happen. Oh, core. Okay, reading comprehension. Gotcha. All right, and they didn't even give me another chance. Okay, so be careful you're looking at the right thing. If it says it's cooler, we're going to go with cooler. Right foot is also going to be cooler because it's a positive correlation. Okay. You think I can get one of those right? All right. Which is the following best interpretation of a correlation coefficient? Again, these are the things you got to pay attention to. Some patients have warmer feet than others. Those who have warmer feet in the left foot generally have warmer feet in the right foot as well. I like that. If we warm up the patient's left foot, then the patient's right foot will become warmer. If we cool the patient's left foot, the right foot, no. So doing one thing to one foot is not going to magically do something for the other foot. We're just going to say it's individual to that person's metabolism. I like those answers. Just individual to their metabolism, and you know, they have warmer feet on the left. They generally have warmer feet on the right. Okay, I think that's why I picked this problem, is because of that. Okay, so let's go ahead and call it there. We'll talk a little bit about what we do next in the next lecture here. Okay, so there we go. Good luck.